Yeah, I can't hear anything coming from the audio, which is why I can't hear you. You might be speaking, but I can't hear you. So today's lesson is about this one of four components of computational thinking. So this brain divided into four parts represents the four core parts of computational thinking. And we've already spoken about some of these: decomposition, abstraction. So breaking it down into smaller parts was our decomposition. Abstraction is making things simpler. So only looking at the removing information that wasn't absolutely necessary to the problem. Then there was pattern recognition, looking for things that could repeat, so that they could, so that we could actually scale up our use less amount of code for more amount of benefit. And then the last one here is represented by this flow diagram, which shows an algorithm put into a graphical form. So algorithms are what we want to talk about today. And in this first slide, it mentions the fact that algorithms can be represented in many ways. The way that you just saw there was a flow chart. That's nice because people recognize the symbols, and it's fairly easy to understand even by people who are not computer technical people. So that's, on the other hand, pseudocode in plain English. Plain English just means, well, just writing things down the way you think it is. Pseudocode is kind of like English, but it has some sort of, I guess you could say, there is a standard format to it. But with both plain English pseudocode and the flowchart, you have certain things that you have to do. You have to say when you start a process and when you end a process, say when you start the entire process and when you end it. Flowchart is kind of what we'll look at today a bit more, I guess. So what do we put into an algorithm? Algorithm is going to be some instructions which are going to be in such a format that they could be followed by a computer or a computer program. And so they're going to include instructions, actions, processes. Nowadays that we have object-oriented languages, we have to sort of broaden the way we do those, I suppose, because we have to consider objects and classes and the properties of those objects. So we have some special diagrams like that for those. But if we just go back to the strictly procedural programming languages, which we've been talking about in this course, there's a little, we do sort of veer along a little bit to object-oriented, and when we're doing the JavaScript, even in this code stuff, if you look at the actual code, we'll see that. But sorry, I'm taking a side thing. We'll focus on procedural. Must have an identified start and end point. Of course, an algorithm must be correct, which means that you must test it. You must test your algorithm. What we used to do when I first started programming is we had the concept of desk checking, which is that you would, and we do that here. You take your algorithm and mentally and on a piece of paper, you write down what would happen as you go through each step in the algorithm. And that's called desk checking, to test that it's actually correct. And then of course you can code the algorithm into some programming language and test it further. Obviously it should be efficient. So there's many other examples in algorithms. As it says here, the first step in an algorithm is we have to consider the level of abstraction and context that we need for it. So if you're if you're creating an action game, you have a lot of computing that's already done for you. And so you would see that in what we were doing with the blocky, right? We're moving that thing around. We actually have an environment where there's a lot of computing there already. But we have abstracted to a very simple thing, which is just move forward, turn left, that type of thing. Low-level programming, we have to, the context is not as rich. Well, what I mean by that is that we don't have a lot of supporting code for us. And so we have to be a lot more sort of specific in everything that we do with that. Not sure what is meant by there, but industrial computer like a robot, I suppose. So sequence is actually a key feature of an algorithm. The idea being that where the order of things is important. So if two programming commands or processes, one follows the other on paper, or one follows the other in the text, in the code that you've written, then in the program, the way that the computer will handle that is the first one will be processed first, second one will be processed second. So the order is important. So you could have the commands that you need to get this ball from here to the exit are like move forward. You're going to move forward 1, 2, 3 times. But you also have a command where you have to turn left. Now, the order of the commands is very important. If you try and turn left now, then you're just going to go up here, right? Or if you go forward and then try and go forward twice before turning left, you're going to go to the wrong place. So the order of operations is quite important, and you should have seen that in the blocky code that you've been doing. That's basically what it's all about in the first couple of lessons. But this is another example of it. In mathematics, it's very important. The order, important. That's one of my bugbears when I listen to people from America, United States of America, when they speak and they say that word important, important. Yeah, they change the T to a D. I don't like that. And I can't believe I just did it. All right, so because it's not spelled like that, right? It's important. There's no D in important. Yeah. All right. Take 2, add 3, multiply by 5. If you take the order as being as it is given, then what will happen is that you'll get 2 plus 3 is 5, multiplied by 5 is 25. Now, you know BODMAS, right? BODMAS, if you have things and you're not setting out the order, we always do multiplication first. So if you actually wrote this, is there a pen here? Yeah. So if you actually wrote this, what 2 plus 3 times 5 equals, the way that you would, who knows what the answer to that would be? 2 plus 3 times 5. That's kind of what this is saying. But what you'd actually do is you do this first, wouldn't you, mathematically? So you do 3 times 5 is 15 plus 2. You'd get 15 plus 2 is 17. Now, that's neither of these operations that you see on the page are that, because this one says take 2, multiply by 5. So that's this plus 3. And so, of course, that's 10. That's equal to this. But the first one, if we just did it without, if we just wrote it down, 2 plus 3 times 5, we'd actually would not get 25. So what we do to make sure that that order occurs, we put brackets around the 2 plus 3, because brackets precedes multiply. All right. So in our writing of our algorithms, we have to be very, very careful, because this is very different than this. So this would give us 25, and this would give us 17. So it's very, very different. So be careful with that. Remember your BODMAS. Remember the order of operations is quite important. Last slide, and I'm sorry that it's so small. There are here two flowcharts. One of them is actually, it has some, I'm not going to say it's wrong, but what I'm going to say is that it's using non-standard symbols for decisions. So decisions should use a diamond symbol. That's what I would, don't do like this. So this is one that I pulled off the internet. Don't do like that. This is the way that we do our flowcharts. And so flowchart is a great way of doing an algorithm. But what we have is we have various symbols. And if you see here, it's not hard. We got 3 symbols that we're going to use here. We've got a symbol for a start and end, or to connector. We call it a connector symbol. That's the oval or round. Or in this shape, in this case, it looks like an egg. That's our connector symbol, start and end. We have rectangular symbols, and those represent processes. Now, if you look at these start and end symbols, they don't have any, okay, so they'll have one thing coming out of them, or else going into them. A couple of things could be. They just come out of nowhere, basically. So it's either got stuff coming out of it or into it. It's not going into, it doesn't have inputs and outputs. It's got either inputs or outputs. So this one's just got inputs. This one's just got outputs. If we look at the rectangular boxes, those represent procedures. Procedures are going to have in this simple form, are just going to have one arrow coming out of them. All right. So he says, yeah. So if you look at this one here, and you might say, well, how's that work, Mark? If you look, these arrows are very small, but the arrows are coming in. You can have multiple arrows coming in, but you got one output coming out. Now, with the decisions, we have two outputs, right? That represents yes or no. So either it's true or it's false. If it's true, it goes one way. So that gives us our opportunity for branching. So when we do branching, we have to have some kind of decision. So this, for example, is a decision box. If you read that, and if I had my glasses on, I might be able to read it. By subscribing to our newsletter, you'll get a discount code and regular updates about special offers. So that is presented to you. And then the idea is, if you look at these arrows, one says, I don't want to subscribe. The other one says, I want my discount. So this one is obviously saying, I want to subscribe. This is saying, I don't want to. So this is yes, and this is no. So that should be a diamond decision box. And likewise here, what types of news and updates are you interested in? News stories, new arrivals. Well, this one here's got multiple outs, and so that's kind of like a case. You can do that. So we've got multiple choices coming out of it. New arrivals, special offers, depending on which one, you should have a different process coming out of those. Yeah, we do have a special sort of how you call it, a structure in programming where you can have multiple choices, you know, A, B, C, D, E, and you know, that's how we build menus, right? You know, which one of these do you want to choose? Now, having said that on menus, nowadays, if you're doing some kind of interactive programming, it is going to be object oriented. And so it's going to be things like event driven, you know, on mouse click, do this, etc. And so you'll have objects which you click on. So, but you know, still, it's going to be a little bit like that. All right, I'm going to stop that share. And I think I might at least pause the recording at that point. Yeah, actually, no, what I should do is, I can't minimize, well, all right, so I will pause it. So what are we to do today? We had a look at this lecture. The other thing to do, as always, is to get onto that code. There are so many exercises to do. And so you need to really get onto it. It's not like there's 3 exercises and then you're done. So I noticed that I got like 20 people in this course. That's very good. But if you look at, okay, so let's see how we're doing. So I got Musab, who's our newest student. It's like burning ahead to lesson 10. And Nino, and yeah, okay. So you guys got the rest of you got a little bit of catching up to do there, right? So let's get started on that. I am going to give marks for this exercise. I mean, so just do it. It's not that hard. I mean, so, you know, here I've been I spent an hour or two doing this as well. I'm not as far as Musa, but so once you get finished those things with the very simple programming things, we've got these sprites. But sprites, the idea when we get to sprites, that's where you're doing the object-oriented programming, right? So you're doing things like click on this and do that. In every case, while you're working away, you can see that there is some underlying programming going on by just show code. And so, for example, we have these codes. So when it says set background image as, and see that in quotes, that means that this is a little module that is going to run. It's somebody else has written a program which sets the background image, and this is a parameter that we're passing to it. And so there's a library of routines and also of these images, et cetera, that we can call upon. And so we are actually building programs here. It's object-oriented programming, but that's not a waste of your time in any way, because not very long from now, you're going to be doing lots of object-oriented programming. In every programming language that you are taught at this college is object-oriented, as far as I know. So when I say that, I mean Python, Java, JavaScript. You'll be using this kind of thing. So when I say object-oriented, it'll be things like, on click, then some routine, that type of thing. So that's what's happening here. These are little routines that are being run. You don't have to write the routines. All you have to do is follow the instructions and sort of put things in, right? It's very sort of easy to go, but you do need to get onto it. All right. So I'm going to stop recording now.